Good evening, ladies. It is 3:51 p.m. on Sunday, October 25th. And I've had a great weekend, but just now getting to making the video. We're going to study functions, graphs of functions, transformations of functions. So I need you to remember for any function, f of x, we can look at the graph of that function and transform that function by adding in different parameters that you're multiplying by, adding by, dividing by, etc., etc. So let's just jump right into it with an easier function than my favorite, y equals x squared. Let's look at y equals the absolute value of x. So this graph looks something like this. It touches the point 0, 0, 1, comma 1, 2, comma 2, negative 1, 1, negative 2, 2. So it is a line with a positive 1 slope when x is positive, and it's another part of a line with a negative 1 slope when x is negative. So I can add a parameter to the outside of this, a plus k, and that will just shift this shape up k units. So if k was positive, the graph would look like this with the slope of positive 1, and here with the slope of positive 1. If k was negative, I would just be down here with the slope of positive 1 on the right hand side and the slope of negative 1 on the left hand side. Good? So any constant on the outside, I use k, but it could be a, could be b, c, whatever. Another important transformation is if we add or subtract on the inside. That one's a little trickier, only because you have to remember that it works a little differently when you're modifying x as opposed to modifying y. So the absolute value of x, our parent function, if you will, absolute value of x looks something like this. And with our parent function, I like to think about the point 0, 0. Not always on the graph, but sometimes it is. That point, the origin, where does it get moved to? Well, where does it get moved if I subtract 4 inside? So I like to ask that kind of question. I do this in my head. You don't need to write it out. But in my head, I kind of think, okay, x minus 4, when does that equal 0? Oh, when x is 4. So if I plugged in 4 right here, 4 minus 4, I would get 0. 1, 2, 3, 4. And the absolute value of 0 is 0. And now if I plug in a 5, 5 minus 4 is 1. So now this point, exactly 1 unit to the right of there, is acting like 1. And if I plugged in a 3, I would get 3 minus 4. And now this point, when x is 3, is acting like a negative 1. This subtracting 4 has moved this line right here over 4 units right here. Now the graph looks like this, parallel to that line, and over here, parallel to this half line. They intersect there, but that not because there's anything special about, it being a subtraction here. It just is a fact of the way the graphs look. So, horizontally shifting inside. So we write this more generally by saying if y equals f of x, if y equals f of x, then I can transform that function into y equals f of, I use x, and then I use minus h plus k. K, if it's positive, shifts up vertically. Vertical shift. If it's negative, shifts down. Vertical shift. H If it's negative, moves to the right. Negative moves to the right. So it's a horizontal shift. And if it's x plus an h, then that moves back. Good? To the left. Let's also take a look at a parameter that would stretch the graph. So if we had the equation y equaled the absolute value of x, and then I graph the function y equals 3 times the absolute value of x. We know our parent function by now. I'm going to draw it quickly. But now if I plug in 1, I get the absolute value of 1 times 3, so I go up 3. And if I plug in negative 1, I get positive 3 as well. So the graph is rising quickly, more quickly than the absolute value of x by a factor of 3. So that we say that this graph was vertically stretched. If I had used a number like negative 1/2, again, I get 0, 0, but if I go over 1, I would get negative 1/2, and over here I would get negative 1/2 as well for the y coordinate. And this graph is supposed to be more open, wider, if you will, than the parent function, and it's flipped down because of the negative. All right, we can do the exact same thing with a horizontal parameter. Y equals, it's harder to see here with a horizontal parameter because if I said the absolute value of 1/2 x, then that's equal to the absolute value of 1/2 times the absolute value of x, and that's equal to 1/2 absolute value of x. So you wouldn't know if I had a parameter on the inside or the outside for this function. So I'm just going to make a function up to show you how it changes. Say I had a function that looked like this. Totally made up. You don't need to worry about how it's defined. But it goes through the point -4 comma -4 comma -4. And it jogs over here to -2 comma -4. And then it goes straight up here to the point 2 comma 4. And then it jogs over to the point 4 comma 4. Okay, if that's my function, I could graph the following transformation. So this is the function y equals f of x. And now I'm going to graph the transformation y equals f of 1/2 x. So again, from the graph, I can read these points. Points on the graph. I've got -4 comma 4. So that means f of -4 equals -4. And -2, f of -2 equals -4. And f of 0 equals 0. That's right there. So I start playing this game. What would I have to plug in here for x to get a 0? Well, that's just a 0. And so that point doesn't change. It would be right there. But then I ask myself, what do I need to plug in for x so that I would get a -2? I have to plug in x equals -4 now. So that 1/2 has transformed this point, x equals -2, into x equals -4. Good? So that means I plug in a -4 here. -4 times 1/2, that's -2. F of -2. F of -2, that's equal to -4. So I've transformed this point. It's moved over here, and now the graph does something like this. By the same logic, what do I have to plug in to get a -4 for x? To get a -4, I'd have to plug in -8. Negative 8 times 1/2 is negative 4. F of negative 4 is negative 4. So we're out here. So this graph has gotten stretched by a factor of 2. It would look something like this. It took that original shape and it stretched it horizontally. Do you see how that's different than a vertical stretch or shrink? So little different with the following parameters. If we look at y equals a times f of x, or if we look at y equals f of b times x. All right, so if I have an a value here, if a is positive, then the graph stays in its normal shape or it's flipped over the x-axis. If it's negative, flipped over the x-axis or keeps its shape. So that's when a is negative. If a is bigger than 1, then we have a vertical stretch. And if a is less than 1, but bigger than 0, talking about the absolute value of a, then we have a vertical shrink. For this parameter, it's all flipped, kind of like h and k. If b is positive, it keeps this shape here. If b is negative, then it's flipped over the y-axis. But in this case, if b is bigger than 1, we have a horizontal shrink. And if b is between 0 and 1, we have a horizontal stretch. Good. We'll practice in class tomorrow. I'll show you some problems that we'll be graphing based on knowing the parent function and how those transformations work.